Is it working out? Yeah. Okay, here we go. Okay, so last section of this chapter is called 8.7, and we're working in base E, and we're doing a natural log, something that you've never seen before. You're just going to get a little taste of this, but this is something that you would see in calculus and college algebra more than you'd see at an Algebra 1 or Algebra 2 level. Algebra 2, you get exposed to new things that you would see. The more math you take, the more you would see a natural log. So, what's the difference? On your calculator, you have an LOG button. Everybody knows where the LOG button is, correct? On your calculator. And you know I told you that your calculator only works in base 10, right? Mine is underneath the LOG button. There's an LN button. Is it underneath it, or next to it, or above it, or somewhere on it, right? There's an LN button. LN stands for the log of the natural, but we call it the natural log. The rest of the world calls it the log of the natural, and that's why it's called LN on your calculator, but it's really called the natural log, and we're going to study what a natural log is. Again, this is used for higher level math classes. Calculus uses this all the time. College algebra uses it all the time. Anything past calculus, they use it. So, what's ln and how do we use natural log? E is an irrational number, like pi. People celebrate Pi Day on 3.14. People celebrate E Day. E is the irrational number 2.71828. They celebrate it on February 7th because it's 2.7, right? So a lot of higher level math classes can celebrate E because E is an irrational number. Just like you know pi. When did you learn pi? Elementary school? 3.14? You guys learned elementary 3.14. That's the most famous irrational number that you've ever learned, pi. Well, if you ask higher level math classes, they know this is the popular irrational number in higher level math classes. It's called E. Just like pi is a Greek letter, this is a letter. This Greek letter stands for 3.14. This English letter, E, stands for 2.718, correct? It's just something, so you learned about the number pi. That doesn't even phase you about the number pi, so the number E shouldn't phase you either, right? The number pi or the number E. This is just a Greek letter, and that represents a number in math, and this is an English letter that represents a number in math. I'm just going to keep going here. I'm just going to keep going. So this is what I'm going to show you, is this right here. So the log, what you learned is base 3, or you learned the log of base 4, or you learned the log of base 10 so far, haven't you? Do you notice what all these numbers are? They're called positive integers. They're not 3.1. They're 3 and 4 and 10. They're whole numbers, right? Well, there's only one natural log. And natural log, you write it like this. You don't write LOG. You write LN. Thank you very much. No. LN of 3 or LN of 4. There's a little base number. It's never there. It's always understood as base what? It's the only base that you can only use in natural logs. Look at logs. Logs, it was base 3, base 4, base 10, base 7, base 8. There's a whole bunch of base numbers we've already learned, right? There's only one base number when you work with the log of the natural. There's only one base number. What's the only base number? The base E. It's base E. Little e. And what does E stand for in math? 2.718 I don't have that memorized like pi. It'll never be there. You'll never see it on the ACT. You just need to know that when you're doing a log of the natural, that this is always understood as base what? E. And what does E stand for again? 2.718 Yep. Okay. So right here. The log of the natural 4 equals x. So far, so good? Everybody following that spot right there? I skipped a little bit of stuff, but there's really a little what there, but it's never going to be there. I'm underlining it. Everybody see that there's a little imaginary e right there, correct? We're going to do the same thing because the logs of the naturals and the logs are exactly the same thing. The only difference is the base number is e, 2.718. How do I change this from the log into exponential? Can I do the loop around? How do you do the loop around? You start with the what? The base, which is e, raise it to the what? X, and it has to equal 4. And there it is. Everything we've learned so far is exactly the same thing that we're doing today. Faster pace, because we learned the logs, probably 4 sections, 5 sections. We're only learning natural logs for 1 day, because it's the same concept. So, here are all the rules. These are all the rules. The natural log of e of e, the natural log of e, if these two are the same, the natural log of e is 1. The natural log of e is 1. How do we know that's right, you guys? Can I do the what? The loop around? What's e to the first? Does it equal e? Yeah. The natural log of 1 equals 0. E to the 0 equals 1. 3 and 4. Ready to start 3 and 4? If I want to break up a natural log, are you guys following number 3? If I want to break up a natural log and there's a division sign, if I want to break it up into 2 natural logs, there's a what sign in between? A minus sign. If there's a multiplication and you want to break it up into 2 natural logs, there's a what sign in between? A plus sign. Is it exactly the same thing that we've been doing? Yeah. Here's something. The natural log of e to the 5th equals 5. Okay, why does it equal that? What can I do with this little 5, this little exponent? Can I put it out where? I can put it out in front. What's the natural log of e? What does the natural log of e stand for? 1. Natural log of e stands for what? 1. What can I replace the natural log of e with? 1, and what's 1 times 5? 5. Never forget that. What does the natural log of e always equal? 1. You could send a Valentine note. Somebody came up to the front of the class, and on Valentine's you could put, "You are the L&E for me." It rhymes. You are the L&E for me. Because what does L&E stand for? 1. You are the one for me. Isn't that a cute Valentine / mathematical brain working with you are the L&E for me? Isn't that cute? Somebody came up and said, "I've got something. I want to put something up on the board." It was just a fun moment for them. Okay, this one right here. This one's more college algebra. E raised to the natural log of x equals this number, x. This is more college algebra. If you see e raised to the natural log of 4 on the ACT, what's the multiple choice question? The answer is probably going to be 4, but that's more of a college algebra type problem, number 6. Okay, let's do all the properties. Let's do all the parts now. Here we go. Part 1. Part 1. Write in natural log form or in exponential form. Do you guys remember putting the log in log form or in exponential form? Same concept. This is in what form? Exponential, and they want you to put it back into natural log, or the log of the natural. L and E. You need to figure out where you should put the E, the X, and the 23. Well, you need to fill in the little guy down there. This big guy equals big guy, just like we did on the first part of the test, right? And you guys all did a nice job and got this right on the test. Where do you think the E should go, the X should go, and the 23 should go? And then you can check it to see if you did it right, if you put them in the right spot. Where should the E go? The first slash, second, or third slash? First slash. What should go in the second slash? 23. What should go in the first, or the last slash? X. How do you know you did it right? Do the loop around. E to the what? X equals 23. But really not going to be written there. What do you have to erase? Because it's never in the problem. What do you have to erase as your final answer? The E. That's not there. It's just not there. No book writes it. No book writes it. That's what the book will write. Natural log of 23 equals X. But you have to know that if it's the log of a natural, it's always base what? E. Why do they do that? I just want to explain something to you guys in algebra. X plus 2, correct, you guys? What's the little imaginary number in front of the X? 1? Do they ever show 1? Or do you just know that it's a 1? That's how, this is so basic. Obviously it's 1x. Why should I put a 1 there, right? The higher level you go, this is supposed to be easy for a really high mathematician. Everybody knows that it should be a base E. Why should you write that? That's so above higher level mathematicians. You don't write the E. Just like you guys never wrote the 1 back in algebra. It's above them. It's way above them. You leave it out. That's just the way you do things in math. So, okay, let's do another one. ln. You know it's ln because what's the dead giveaway? You don't write log because there's a what in the problem? There's an E. If there's an E, it has to be ln. And then you got to fill in this little guy, you got to fill in this little guy, and you have to fill in this little guy on the test, first part of the worksheet. Well, I'm going to put a little E here because I know all natural logs work in base E. And I know it needs to be E to the something, right? E to the something, and it's E to the 4. So I know the 4 has to go there, and the X has to go there. And then all I ask you to do, please, to get better at it, if you're going on to college algebra, is erase that. Because that's supposed to be the way you're supposed to write it. The other way around. It's in natural log form. Can we put it into exponential form on the test? That's why I said we can handle, we don't need a review day yesterday. There's a little guy down there, that's a what? E. It's E to the what? E to the 1.2528 equals what? X. Final answer. And then the last one, E to the what? E to the X equals 25. First part on the worksheet. Can you handle the first part on the worksheet? Should take you too long to know how to go from exponential to log and log back to exponential. Good to go? Okay, next part. I think there's 4 parts. I'm not for sure. But. Part 2. Write it as a single log. Write it as a single log. Did we do this on the last test? No, that was 8.5. It's going to be on the next test. I'm just going to take, let's make this a 2 instead of a 4, so I don't have to use my calculator. Let's just make that a 2 instead of a 4. So, we want to write this as one single log, the log, natural log. The first thing I need to know is 3 squared is what? 9, right? So this is a 9. On the test, do I just add those 2 together to get my final answer of the natural log of 15? Is that what you're supposed to do if there's an addition sign in between? You're supposed to multiply. So the final answer is the log, natural log of 54. Final answer. The next problem. How many more of these do I have? Ooh, we got a few. Example number 6. Natural log of 9 plus the natural log of 4 minus the natural log of y. We're going to put this all together to write a natural log, correct? Log of the natural. Log of the natural. Addition means to multiply. 9 times 4 is 36. But you have also a minus sign in the problem, so what are you going to put? A division sign, correct? And you're going to divide it by what? Y, right? Are we done? We are done with the problem. Good to go on that one? And now, do we have one more? Yeah, one more. Last one of these. Again, combine them as one natural log. Oh, did I really do this problem? This is going to be big. This is going to be big. I don't even know what the answer is because I accidentally went too big. I'm going to go like this and take this part off because we're going to go way too big. There, that's a little bit better. So anyway, the 3 comes up here and it becomes 5 to the 3rd, and the 2 comes up there and it becomes 2 to the 2nd, correct? And 5 to the 3rd is not 15. 5 to the 3rd is 3 5s, which make 125, correct? It's 125 times 4, right? 120, this makes 125, and this makes 4, and you have to actually multiply them together, which makes 500. Final answer. Shortened it up so we didn't have to use a calculator. Any questions on the second part of the assignment? The third part of the assignment, I think. That's it. I think there's only 3 parts because, yeah. How to solve now. How to solve for x. So there's only 2 ways to solve these problems, you guys. There's only 2 ways to solve the problem. So I'm going to try to ingrain this in. If it's in exponential form and there's no natural log in the problem, everybody see the difference between these 2 types of problems? If there's only an e, the objective is to get e alone. Got that? We're going to subtract 4. What's 10 take away 4? 6. We still got to get e alone. Divide both sides by 3. E to the 2x equals 2. So far, so good. So there's only 2 types of problems. 2 types. If there's an e, you get it alone. If there's a natural log, I'll explain that in a second. Okay, just like we did yesterday. Do you guys remember yesterday? I'm going to bring back yesterday. 2 to the x equals 15. I think that was even one of the problems from yesterday on the notes. 2 to the x equals 15. Will we ever get these to look the same, the 2 and the 15, yesterday? Did we log both sides? Same concept. This is a number e, 2.7, correct? And this is the number 2. Will we ever make them look the same, those 2 base numbers? Instead of logging both sides, we natural log both sides. Same concept. ln e, 2x. ln 2. ln e, 2x. ln 2. You natural log both sides when you do e's. What happens to that little 2x? Where does that have to go? Where does this little 2x have to go? Out in front. So now we have 2x ln e equals natural log of 2, right? We have 2x, natural log of e equals the natural log of 2. But what does the natural log of e stand for in math? ln e, 1. Yep, ln e stands for what? 1. So what happens to the ln e? Cancels out, correct? Because 1 times 2x is still 2x, right? So you're going to think this is really dorky. The basketball team could have yelled out, ln e, we're number 1, right? In the section, they could have yelled out, ln e, right? Because they're number 1, and ln e stands for 1, right? Dorky, I know. Anyway, this is God. How do you get x alone to solve for the problem? Don't you have to take the ln of 2 divided by 2? So don't you have to use, now you get to use the ln button on your calculator? So to hit the ln button, natural log of the natural, take natural log of 2 and divide it by 2, and go out to 4 decimals, and x equals 0.3466. Final answer. I'm going to do 4 of these, so hopefully you understand that. There's only 2 types of problems at the end of the test. Either you get e alone, and then after you get e alone, you need to ln both sides. Does that make sense? Get e alone, and then after you get e alone, you ln both sides. Everybody got how to do the e problems. If there is no e, and there's only a natural log, it's even easier. Because don't you have to put it into e4? E to the what power? E to the 4 equals what? 2x. Okay, now on your calculator, right above the ln button is the e to the x button. Everybody's got an ln button, and everybody above the ln button has an e to the x button, correct? So in order to get to the e to the x, you have to get to the second button. So get your second button, and now it looks like e to the flashing, blinking, right? And all you're going to do is put e to the what in your calculator? E to the fourth, which is 54 something. Isn't it kind of cool that e, what's e again? 2 point what? What happens if you took 2.7 and erased it to the fourth power? Is it going to be about 54? But there's a shortcut button on your calculator. Instead of memorizing e to 2.7, there's an e button. Isn't that nice? And then what do you have to do after you do e to the fourth? Divide both sides by 2 to get x alone. Final answer, 27.299. Final answer. So let's go through two more, and that's all for the notes. That's all we learned. We learned about the E button, or the natural log. Let's do two more problems, and we are done with notes. Two last ones on the test. I gave you two of these on the test. If it's already in this form, don't you just have to put it into exponential form? But there's something wrong with this one before I can put it into exponential. What do I have to do first? Divide both sides by what? Divide by 2. So I have the natural log of 5x equals 3 now, correct? The natural log of 5x equals 3. If it's in natural log form, what form are you going to put it in? E. It's going to be, a little guy is the e. E to the what? E to the third equals 5x. Now you're going to take out the calculator and do e to the third to the third. Divided by 5. Final answer, 4.017. 4.017, final answer. There's two types of problems. If it's a natural log, you put it into exponential form. What happens if it's an exponential form? The first thing you do, if it's in exponential form, go back over here to the notes. The first thing you need to do, if there's an e, you need to get what alone? You have to get e alone? That's the first thing you do. There's not a lot to do. Get e alone by dividing both sides by what? 4? E to the 3x equals 4. E to the 3x equals 4. Did we get e alone? Okay, now go back to the notes one more time. How do you figure out what x is? Right here. Once you get e alone, what do you have to do to both sides of your problem? Instead of logging both sides, you are going to natural log, or the log of the natural both sides. Where are we? Right. Ln e to the 3x. Don't forget to do both sides. Whatever you do to one side, you have to do to the other side. What happens to that little 3x? Where can it go? Out in front. What's ln e? 1. Hopefully you're not going to ever forget this as long as you live. ln e is 1. That could be an ACT question. They could just put ln e on there, and you might have to, it might be 0, 1, negative 1, 2, and you have to quickly look at the problem and go, that's right, ln e is 1. I can quickly move on to the next ACT question. You could plug it into your calculator, and you're going to get 1 also. ln e is 1. So anyway, this is gone, because it's 1. Whatever the natural log of 4 is on your calculator divided by 3 is your answer. And that's all we are learning about what ln is. And I'll just tell you really quick what it is. Divided by 3, it's 0.462 if you care. 0.462. Good? So, recap. Let me just look at the worksheet really fast to recap what we've learned so far here. Yeah. So here's what you're going to do. There's 4 parts. Here is the first part. The first part is this. It's in ln form, and they want you to put it into exponential form. That's the first part. You have 4 of those to do. How long will it take you to do those 4? Not long. The second part, it's an e form. They want you to put it into natural log form. Take away the e at the end. The second part of the assignment is to combine things together. And the third part, I think you got 4 of these. I got the e's on the left side and the natural logs on the right side. So you can do all of these and then you can do all of those. But there's 2 types, E alone, natural log both sides, or if it's a natural log, put it into E form. You know, you guys? Okay. Pass it up. Put it back. I'll put the answer key up here too. 3, 4, 5, 6. That goes to 82. I'll put the answer key up here too. Thank you.